For section 14.3, we will be multiplying polynomials by monomials. So that means one term by multiple terms. And the one property that you need to remember is that when you have the same base and you multiply, you can add the exponents. So for example, here we have a to the m power times a to the n power. That's going to equal a to the m plus n power. So for example 1, we need to multiply. So we're going to start off by just multiplying the two coefficients. So 2 times 3 is -6. And then we are going to multiply the variables. We have x to the 4th times x to the 5th, which would be x to the 9th because we just add them. So our product, our answer is -6x to the 9th power. Okay, similar here, still a monomial times a monomial. Multiply the coefficients, so 8 times 6 is 48. And then letter by letter, we have g to the 2nd power times g. And remember, if it's just a variable without an exponent, the exponent's actually a 1. So this would be g to the 3rd. 2 plus 1 is 3. And then the h's, h to the 5th times h to the 3rd would be h to the 8th. Then when we have a monomial with a trinomial, we have to really distribute. So 4 times 5x squared. So 4 times 5 is 20. And then x squared is the only thing to multiply the x by. There's nothing else to multiply, so we just bring that down. Then we do 4 times 3x. Well, 4 times 3, everything's positive, so a positive 12. And again, just that x, nothing to multiply that x by. And then last, we have 4 times 1. So that would be 4. So the product would be 20x squared plus 12x plus 4. And another one here, we have 2x times 3x squared. So again, the coefficients, 2 times 3 is 6. And then x times x squared would be x to the 3rd. Then we do 2x times 2x. 2 times 2 would be a positive 4. X times x would be x to the 2nd. And then we have 2x times -4, so that would be -8. And there's only that x in the front, so that x gets brought over, and we have our product. Now for our last example here, we have a word problem that Crystal is making a planter box in the shape of a rectangular prism with a square base. She wants the height of the planter to be 3 inches more than a side length. If she needs the volume of the planter to be as close as possible to 6,000 cubic inches, what should its side length be to the nearest whole inch? So for step 1, we have to define what we know. So it said she wants the height of the planter to be 3 inches more than a side length. So we don't know what the side length is, so we're going to call it S. And the height needs to be 3 inches more than that, so that would be 3 plus S. Now the volume is length times width times height. So that means there's 2 sides, length and width, so that would be S times S, and then times the height, which is 3 plus S. So if I simplify that, S times S out front is S squared, and then I have to multiply that by 3 plus S. So zoom in here. We have to distribute. Oops. S squared times 3 would be 3S squared, and S squared times S would be S to the 3rd power. So we would figure out the volume using that formula based off what we know. So now it says use the formula from step 1, that 3s squared plus s to the 3rd power, to guess and check. What side lengths get you closest to 6,000 cubic inches? So I'm just going to pick a random number. I'm going to pick 10. So I'm going to do 3 times 10 to the second power plus 10 to the third power. And when I plug that in the calculator, I get 1,300. So not quite big enough. So now I'm going to try 15. 15 gives me 4,050 when I plug that in. So let's try 16. We're getting closer. And that is 4,864. So maybe I need to go up by 2 more. Let's try 18. So I'm going to do 3 times 18 squared plus 18 to the third power. That is 6,804. So it looks like I went too many. So now let's go back to 17. That is 5,780. So if we go back to the word problem, it says if she needs the volume of the planter to be as close as possible to 6,000 cubic inches, what should its side length be? So it's definitely either 17 or 18. We need to decide which one gets us closer to 6,000. So roughly 17, the 5,780 is roughly 200 away. And the 6,804 is about 800 away. So the 17 is definitely closer to 6,000. So the side length needs to be 17 inches.